At first, it was an ordinary sunspot, one of the many that emerge and fade on the sun's surface. It appeared on the eastern edge, unremarkable and fleeting. But as days passed, it grew at an astonishing pace, swelling to a size 17 times larger than Earth. Scientists named it Active Region 3664, and soon, it lived up to its formidable title. This colossal sunspot unleashed a series of fierce solar flares, some so powerful that they triggered coronal mass ejections directed straight at Earth. The result was one of the most breathtaking auroral displays in recorded history, with vibrant lights painting the skies of regions that had never witnessed them before. According to NASA, this was the most powerful geomagnetic storm in 5 centuries, so intense that even underground observatories detected its impact. Yet, the sun did not settle after the tempestuous storms of May. Instead, it continued to release bursts of M-class and moderate X-class flares, keeping space weather experts on constant alert. Then, on October 3rd, an enormous X9.0 flare erupted from the sun's central disk, the most powerful seen in 7 years. Within a week, Earth was struck by a formidable G4 geomagnetic storm, igniting dazzling auroras in unexpected places and disrupting radio communications across various regions. All of this pointed to one inevitable conclusion: the approach of solar maximum. And now, NASA has confirmed it. The sun's magnetic field has flipped, signaling that the solar maximum has officially begun. But what does this mean for our planet in the months ahead? How long will this heightened period of solar activity last? And most intriguingly, will it contribute to global warming? The rhythmic heartbeat of the sun. Though the sun appears to us as an unwavering sphere of light, its nature is far from constant. Approximately every 11 years, it undergoes a profound transformation, a cycle of activity that reshapes its magnetic field, influences space weather, and alters its very appearance. The discovery of this solar cycle dates back to the late 18th century when astronomers noticed a pattern in the occurrence of sunspots. These dark patches on the sun's surface were not random. Rather, they increased and diminished in a rhythmic cycle. Further observations revealed that this cycle spanned roughly 11 years, a pattern that has since been meticulously tracked. For years, scientists monitored the sun's activity solely by counting sunspots, but as observational techniques improved, they uncovered 2 additional changes linked to the solar cycle. The first was the sun's magnetic field, an immense, ever-shifting force that undergoes a complete reversal with each cycle. North becomes south, and south becomes north. This pole reversal marks the midpoint of the cycle, occurring around the time of solar maximum. The second discovery was the fluctuation in the sun's overall activity. Solar wind, flares, and coronal mass ejections all intensify during the solar maximum and subside during the minimum. Because of these findings, modern monitoring of the solar cycle now extends beyond sunspots, encompassing the sun's magnetic polarity and broader activity patterns. Since the first recorded solar cycle, each successive cycle has been numbered. We are currently in solar cycle 25, but history holds evidence of cycles that defied expectations. While most cycles followed the expected pattern of rising to a peak and then declining, there were 2 enigmatic periods that still puzzle scientists today. One such anomaly was the Maunder minimum, 1645 to 1715, a time of extraordinarily low solar activity. During these 70 years, sunspots became almost non-existent. Astronomers recorded only about 50, whereas thousands typically appear in a single cycle. This quiet sun coincided with a period known as the Little Ice Age, when global temperatures dropped dramatically. Rivers such as the Thames in London, which rarely froze, turned to ice, and Europe endured harsh winters. Following the Maunder minimum, another period of diminished solar activity occurred, the Dalton minimum, 1790 to 1830. Though less extreme, it too coincided with cooler global temperatures. Major volcanic eruptions, such as the 1815 explosion of Mount Tambora, contributed further to the chilling of the planet. The aftermath of that eruption led to the year without a summer in 1816, causing widespread crop failures and famine in Europe and North America. A solar cycle full of surprises. Solar cycle 24, which began in 2008, was particularly weak. Sunspot numbers and overall solar activity were well below average, making it one of the least active cycles in over a century. Scientists, caught off guard by its subdued nature, began to question the underlying causes of solar variability and whether another grand minimum might be on the horizon. Yet, when solar cycle 25 commenced in December 2019, it quickly defied expectations. Initially forecasted to be even weaker than its predecessor, it instead surged with remarkable strength. By August 2024, the average daily sunspot number had reached 299, more than double the anticipated value, a level not observed in over 2 decades. Moreover, its peak arrived sooner than expected. Early predictions placed the solar maximum in July 2025 with around 115 sunspots, but as activity intensified, forecasts were revised. By early 2024, NOAA's Space Weather Prediction Center adjusted its expectations, predicting the peak would occur between January and October 2024, with a far higher estimate of 137 to 173 sunspots. Then, on October 15, NASA officially declared the arrival of solar maximum. However, this announcement does not signify the absolute peak of activity. Determining the true apex requires months, if not years, of observations. For now, scientists expect the Sun to remain in its maximum phase for another year before it begins its gradual decline into the next solar minimum. Echoes of the past. Historic solar storms. Throughout history, powerful solar storms have left their mark on Earth. Among them, the Carrington event of 1859 remains the most intense geomagnetic storm ever recorded. British astronomer Richard Carrington witnessed an immense solar flare, and just hours later, a coronal mass ejection struck Earth. The ensuing storm sent telegraph systems haywire. Some operators even reported electric shocks, while others found their machines working without batteries, powered solely by the storm's induced currents. Auroras stretched as far south as the Caribbean, glowing so brilliantly that people could read newspapers beneath the night sky. Other storms followed: the New York Railroad Storm of 1921, the Apollo Era Storm of 1972, and the Quebec Blackout of 1989, which left 6 million people without power. More recently, in 2022, a solar storm destroyed 40 newly launched Starlink satellites, highlighting our growing vulnerability to space weather. Today, a Carrington-class event could result in damages exceeding $2.6 trillion in the U.S. alone. Solar maximum and global warming. Is there a link? Does increased solar activity contribute to rising global temperatures? While solar maximum brings a slight uptick in the total solar irradiance reaching Earth, these fluctuations are minor and temporary. Data from the past century show no long-term correlation between solar cycles and the global warming trend. Earth's temperature has continued to rise despite no significant increase in solar energy output since the 1950s.